you. Thank you, Kelly.
It's a pleasure.
Thank you so much. Well, I'm obviously overwhelmed by the honor and by the kindness when I found out and heard that I was being selected for this prestigious award. And sometimes you wonder whether it's deserved, because we all of course try our best in our research, and we always build on the shoulders of giants, as we say. You know, we build on top of the things that we learned from other people and from people we worked with, and that's obviously particularly true in this field. And so I want to start this lecture by remembering Antonio Zampolli, who was a pioneer in his age. When I started with my research, people didn't consider language resources very important, or evaluations for that matter, because everybody was sort of by themselves looking at things, whatever they felt they were to build. And to begin with a rigorous evaluation campaign, with having language resources that are being shared among different partners, that was new at the time, and was actually generally not well accepted. We had to really push back. Some of our old-timers know how hard we had to fight to even get that concept through in the people who funded us and the collaborators. So we should remember Antonio as a visionary and pioneer who started off a lot of this activity, and that gave us a chance to really move on and build and do greater and better things. So let me call this whole talk about talking about connecting the world through language. That is really the passion that has driven me, and if you ask me why did we do the things, it's really ultimately being driven by a practical goal. We want to make our world simply better, and we know that there's a lot of misunderstandings in this world, and some of them are simply caused by language or by misunderstandings of culture. And so it's the simple question is, what can we do through technology? I love this picture. It really shows the world that we're in. We are in a world today where really the Stone Age and the most modern high-tech capabilities meet each other and are somehow smoothly flowing together. There are 6 billion telephones nowadays in the world. It's an unprecedented exchange in communication. So someone in the most remote part of the world can simply reach out and connect with somebody in any other part of the world on the planet. That's just amazing. We never had this before in the history of humankind. And so very quickly, the most complicated and difficult problem that emerges is the differences in cultures and the differences in language. As you all know, there are 6,000 languages in this world, and they define us. We know that they define our identity, our language, our culture. They give us pride and individuality. And so we don't want to remove this. It's critical and important that we maintain it. At the same time, we do grow together, and we really do meet each other, and it's necessary. In the developing world, when people are asked, what would you rather have, a shower or a cell phone? In the developed world, people would say, well, if you really push me hard, then I would rather have a shower than a cell phone. In the developing world, it's the other way around. The cell phone is so much a part of survival in this new world, in this part of the world that is emerging, that it is a critical tool. And in the many humanitarian things that I will talk about a little bit later, we've found this time and again. People don't have healthcare, they don't have glasses, they don't have teeth or dentists, but they all have a cell phone, no matter where you go. And with that in mind, we just are in an unprecedented situation where people really do connect, and we have to find solutions for this. Of course, right in Europe, we have it is particularly visible also where it's politically a mandate to make sure that people connect in their own languages. There are 23 official languages, and then of course local dialects and so on. And for people to be effective, once again, it's coming across this language barrier. So how it's done? Well, many would say, well, why doesn't everybody speak just English? And indeed, the intellectuals and the people who are in research communities, they attend conference, and most of the time we do speak English to each other. But if you really look at the statistics, it's only about 30 to 40% of Europeans who speak it well enough that they can communicate with each other freely. So once again, it's neither desirable nor practical to simply say we all agree on one language. Now, if the European Commission or the European Parliament have a mandate to do everything in everybody's local languages, there's human effort. We have a great working relationship now with the folks in the European Parliament. They have an amazing directorate for interpretation and a directorate for translation, where you have some of the most amazing professionals who do this day by day. And it's an incredible effort by which this interpretation is done, but it's also enormously expensive. It takes a lot of training, and it's other than just in the Parliament, in the Commission, it's very difficult to see how the rest of the population in Europe can actually have this type of capability. And so it is, again, broken English or nothing at all. And so it rapidly also becomes a social problem, because the people who have the education to speak English, they communicate, and the more local people who don't, they just don't. They just don't have the capabilities. Last time that happened was the Middle Ages, when the common language was Latin for those who had the training, and the rest of them, well, they just had to muddle along. So that really screams for solutions, and so I was driven in most of my career by this idea to build a practical system that would be an interpreting machine that can interpret between people and be something you can put in your pocket. So it obviously requires 6 component engines: automatic speech recognition, machine translation, and speech synthesis. And when I proposed this in 1978 to my advisor, John Allen, I was at MIT studying on the first and working on the first text-to-speech synthesis system. And I was this undergraduate student, didn't know any better, so I proposed building such a machine, and he simply was very polite, because he knew how hard the problem was, and he said, well, yeah, that sounds like a good idea, go back and continue your work on speech synthesis. So luckily he didn't torpedo my dream, but it took me 20 years to figure out how hard the problem really was, and how many more issues and parts we had to develop. So I went on to work at Carnegie Mellon with Professor Raj Reddy, who was again one of the pioneers that you may remember in speech recognition. He still is teaching at and working at Carnegie Mellon, is one of the grandfathers of speech recognition. So once again, I was lucky and fortunate to learn from the very best, and then work on speech recognition in that. During that time, I also met a visitor, Professor Shikano, I think he is here in the room, who at the time was building a new laboratory in Japan, where they were resuming with this idea of machine translation. It was rejected largely in the Western world, because the ALPAC report and others was considered too hard. But Japan again took initiative and to follow on this dream to really begin building machine translation systems again. So here I was, and I had an opportunity to go to Japan and work on machine translation and ultimately speech-to-speech translation systems. We rubbed shoulders, of course, with other wonderful pioneers, Peter Brown, who was a graduate student at the time at Carnegie Mellon. So we were really surrounded by fortunate people who really had very seminal work going on that we could really benefit to realize a dream like this. Now, very early on, when I was in the 70s at MIT, people talked about artificial intelligence, but it became clear to me at the time that it was lacking 2 very, very painful aspects. People were building expert systems with many rules, and to me, I resolved, it was clear that we had to have 2 things. One is we have to deal with ambiguity of language. Language is ambiguous, and so we have to represent it somehow. Scores, statistics, neural activations, whatever you want to call it, probabilities. And we'd have to learn them. There's no way that we can ever just try to accomplish to put all this knowledge into a machine unless the machine also has learning algorithms and learning programs to do this. And when you say learning, then it has to learn it on something, and clearly that means that we have to connect the machines with human data and interaction, and then make them grow and learn from this automatically. So the consequence, that stimulated then really a great deal of work on language resources, because it became a necessity, a critical necessity for performance and progress to develop. And obviously that generates a cost factor. Generating databases based on which the community can do this costs money, and it's laborious, it takes time. So the things we learned over time was that in speech and translation, there were really these dimensions that make everything more complicated. First of all, do we have to have high quality or low quality? Do we have high quantity? And by and large, I think, perhaps to the chagrin of many of us who like to actually look at the details, quantity very often trumps quality. But both of them, of course, are important, are factors of performance. Then do you have to label the data? Is it labeled? Is it supervised or unsupervised data? That too severely affects the cost, if you think, for example, at conversational data. And then is it read conversational? Is it monomodal, multimodal? Is it language, multilingual data or noisy data? All of these, again, add more complexities. So with these databases, I'll walk you quickly through some of the key systems we then proceeded to develop. And again, all of them were only possible through some of the language resources that were developed in the process. We started with the first video. After some of our initial work on the components, we then had the first breakthrough, if you like, in 1991 and 92, where in this consortium, together with our partners at ATR and in Germany, we could develop and demonstrate a first speech translation system that would operate via video conferencing, as you can see here. It was the first show of feasibility, but totally impractical, of course. It had a very small vocabulary and a rigid syntax, and couldn't put it in your pocket. It took 5 minutes to compute, and all these other things that make it impractical. It took us 20 years almost to bring it to the level where we finally were there. In 2009, Apple came out with the iPhone 3GS, which had just at the time enough computing, and we had spent several years to engineer down all of the components to make them faster and smaller so that they could be packaged into smaller and smaller systems, but we're never satisfied because either the vocabulary was too small and you couldn't say things, or the time it would take to compute would be taking longer than typing, so thereby removing the whole advantage of speech. And with the iPhone 3GS, we hit the sweet spot. That was the point at which the engineering was fast and small enough, and the hardware was powerful enough that we really could put it together. It was then faster. We could do a 40,000-word vocabulary, which allows you more or less to say all the things you want to say in a tourist scenario. So it grew, and at the end, it's now an app on iTunes with 15 languages, and it was sold first as an app. And as I said, it doesn't require a server, runs offline, and that was important for us because we wanted to do humanitarian missions with it, to help medical doctors with it, and it was then also ported to different devices and tablets. And
I took this amazing trip to Spain after college, and with my iPhone, I checked out hostels before booking them, shared pictures as I went. My mom loved that. And I even downloaded this app, which became my personal translator. Where's the train station?
¿Dónde está la estación de tren?
All I really needed was my iPhone and my passport.
So since it was the first system of this kind, it obviously triggered a lot of excitement, and people were eager to try it out, and Apple ran these commercials in 4 or 5 different countries, and so this was, of course, good for us. We had a startup company that was formed by that time that was distributing this over iTunes. Economists wrote rather positively about it in other newspapers, so it was a good development on the commercial side also. And the most exciting thing about it was to really see that thousands of people suddenly, via this App Store mechanism, could really download and use it. So we had people mailing us, sending us emails saying, finally I can understand my mother-in-law, and I can finally do this and that because I can communicate. So this was exciting, and we also then deployed it in humanitarian situations through various exercises where doctors go into third world countries and provide healthcare. You see here some doctors on an iPad communicating with patients in Thailand. We deployed these systems in Thailand. You see here the doctors and the nurses. In Cambodia, we had some exercises, again, medical and humanitarian. See here some of the pictures. Honduras, it's a charity from Pittsburgh that operates in Honduras in a remote village, and doctors providing healthcare in this case. And the exciting thing is that we were there. We were really at a system that could be used. There was finally a test being done by the US government to see whether at a registration desk in a remote area in Thailand, whether a registration desk doctor can communicate well enough with someone to Thai, between Thai and English, so that registration can be done without a human interpreter, in that case, without requiring a human interpreter. And it was shown that 98% of the time was actually sufficient. It's not saying it's not perfect, and that the dialogues at the registration desk are relatively simple, but it was possible. Now, of course, there's a lot more challenges that remain. First of all, that's just 15 languages, or 20 or so. The world has 6,000 languages, and so at our laboratory we spend a lot of effort to do PhD theses and master's theses at driving down the cost. What can we do to make the language technology more language independent, to create the data collection effort, make it cheaper, so that in a way it becomes a push-button process to add a new language. And that's, of course, another vision that needs to be done in order to drive it up in those languages. As you can see, of course, and when you go down this long tail of languages become so small and insignificant commercially that usually there's no funding for doing this. So we must have it cheap enough and simple enough that people themselves can do it in the field for a new language. Now, the other way is, of course, to team up with large partners. Our company was in the meantime acquired and purchased by Facebook. Facebook makes a living of building apps that connect the world by pictures and things, and so they took notice of what we were doing and said, wow, this would be a neat thing to connect the world by language. And so we teamed up. You see our team here in Menlo Park in 2013. Mark Zuckerberg is a wonderful person who is technically extremely savvy and interested, and so the discussions are wonderful, and making that dream happen now essentially can take on a completely new dimension by the reach of a company that has such a global presence. Let me move on to another domain that interests us, which is simultaneous translation. And again, you know, you have many situations where the language problem is a monologue on TV or a speech or a lecture. And so we have a project called UBridge in Europe where we have funding to explore this space and some very nice results. So we're working on areas where companies really have an interest to engage automatic systems. One of them is, for example, weather reports. Human transcribers and translators can't really do this cost effectively for each area, so it's being done in the project. Another one is lectures, and here one of the big challenges is how do you translate lectures into another language when the vocabularies, of course, are much larger, the speed is faster, and so on. So we had a lot of interest in Europe, particularly to do lectures and do lecture translation. Because, for example, at a German university, you may have students who do not understand German, and so German has a handicap by simply not attracting students who wish to learn at a German university but can't because they don't speak the language. So we developed a system that has a diagram like this, and you see it running actually on the right side. It's a system there that recognizes what I'm saying and speaking to you, transcribes it, puts in automatically segment boundaries to know where the sentences begin and where they end, and then perform the translation from one language to the other. The computing is done on a server that runs in the cloud, so that a instructor or a lecturer comes to class, starts the program, and gives his lecture. Now the speech is sent to the server, it's transcribed and translated to another language, and it's then sent to a web page. So every student in the classroom can then pull out their iPhone or iPad or their personal device and then watch the transcript and the translation on their own personal device in their own desk. So it doesn't require any dedicated hardware anymore because it can simply be done through the machines and the technology that they all have with them. And in so doing, you get automatically subtitles to the lecture that is currently being presented and a connection to the speaker, even if you do not understand the language that is spoken. So this was for the first time tried as a prototype in 2005, but then we worked for a couple more years to bring it down to an actual service so that it would run in the cloud, be robust enough that we can serve multiple lectures at University of Karlsruher. And in 2012, we launched it publicly. We had invited some politicians who watched it, and we could then show this actually in action. And at Karlsruher University, at the Karlsruher Institute of Technology, we give lectures now routinely in the large conference hall. The system is constantly running, so people who do not understand German can then follow along in the lecture through this system. Now, translation of lectures is only one part of the language divide. We also have, of course, the slides, the PowerPoint presentation itself. So we're working on translation tools that translate the slides. Again, they are usually very telegraphic and brief. So doing translation there is yet another problem. And then once the lecture is transcribed, of course, it can go in an archive so that the student can later on then pull up the lecture based on certain keywords, and then either revisit the lecture or find a fragment of some element of the lecture that he or she may want to review. Now with German, we picked one of the hardest languages that we could imagine, because in German and Chinese are probably the weirdest language for machine translation. And so this was perhaps in the hindsight unfortunate to begin this with German. As you know, for example, Germans put the verb at the end, which is a huge pain not only for machines but also for human translators, because you never really know how the story ends until 10 minutes later you get the verb. Then you have compounding. A simple word sequence like word recognition error rate is one word in German. And then agreement, that all the endings have to agree with each other when you want to translate into German, let's say. Moreover, in technical lectures, you have then problems with special terms and technical terms, capital coefficients, for example. How do you recognize and what does it mean in another language? And so we need to have vocabularies that adapt automatically to the topic of the speaker. Formulas, when people speak formulas, you don't expect them to be typed out as f of x, but you want to see a formula coming out, so this is another area. And then English words slipping into German lectures. In a computer science lecture in German is generally peppered with English terms. Nobody says, for example, cloud and iPhone. These are English words, and they're pronounced the English way in German. So you don't say Cloud or iPhone or something strange like that. You speak it the German way, and you expect it to be recognized even as a German word. And then worse, these English words in German are then added with a German morphology. So you have webgecastet, downgeloaded, and cloud-basierter Webcast-Zugriff. It's a disaster. So you need to now decompose a German word according to German morphology into English words that get inserted into this. And that is routinely happening on all the lectures in German. We also had a chance to give a lecture in the European Parliament, and since that initial thing, we developed a great friendship. To our surprise, the Parliament is not at all hostile towards our technical activities, but they really embrace it and are looking forward towards really solving the language problem by simply collaborating between the human effort that they do, and the human effort is fantastic, and technology that can be provided. Now, what do? We look at two particular instances. For example, the humans are still doing so much better a job in the Parliament than we do with the technology. But there are certain lectures, for example, that they don't like to do. For example, voting sessions, where every time they say, oh, vote is 23 votes in favor and 22 votes against, and the motion is accepted. And the next one is 21 vote in favor, etc. So it's very, very boring to recognize it and translate it, but it's also critical. You can't make a mistake. So they would much rather have a cruise control when it gets into this boring section, that you turn on this automatic system and let it do this until it gets more interesting. So that's one system that we're looking at. Another one is essentially component technologies like terminology that they use to prepare for the human effort, and see that we somehow use that from the automatic mechanisms based on the material and documents that are online. Okay, third area, very quickly. This area is multimodality. When we talk as human beings to each other, it's of course not only spoken and it's not only written. We also communicate by eye contact, by gestures, by the environment that we're in. And generally we don't really know when we speak, and we have to know in what context something is spoken so we can interpret it correctly. So if we have an open meeting situation and you have a person here who wants to have the other two people being translated or wants to know something about the other people, we need services that really know something more about the human being based on visual information and acoustic information. So in yet another wonderful project we had funded by the EU, European Commission, we had a chance at looking at all these multimodal aspects, where someone is pointing to, where they're going. We have a room, we equipped a room with various sensors and generate a wonderful data resource, which is now shared and distributed via ELRA, so that it's essentially available to the whole community. So we can now do tests and have an objective evaluation mechanism for multimodal communication in lecture scenarios. As a result of it, we can do improvements on face identification. This one down here on the right is very interesting to me with focus of attention tracking. You need to know where somebody is looking in order to be able to tell what actually people are saying and why they're saying it. You need to know who you're looking at in order to interpret the speech. And all of this is critical elements in order to really understand the meaning and the point of a particular speech pattern, as well as a communicative gesture or action. On the output side, it's possible to have heads-up displays and targeted audio devices that give audio beams only to one particular person in the audience, so that someday I really do believe it may be possible that we can all sit around a table. The machine recognizes which language we speak. It can recognize us in our own language and then beam an audio translation into our ideas in our respective language. And if the language barrier becomes this transparent so that we can really communicate without feeling the difference anymore, then I think we will have arrived. So where do we have to go from here? Performance is of course key, and the big question that is obviously in many people's mind is always, is human performance possible? Is perhaps superhuman performance possible at some point? And that of course makes you philosophical, because what is my role in all of this and how will this play out and give us a chance to operate, or how will it affect and improve our world? I was particularly intrigued by a result that Khalid Shukri and his team did with us. Victoria Arans worked on this and a number of people in their team. And what they did is, in a project called TC Star, is look at how much content was actually understood based on an automatically produced speech translation of a lecture, in this case European Parliament lecture, or a humanly produced lecture. And you see this result on the right. And it turns out the performance is not that different anymore between the human machine and the human and the machine. And what's more striking is, what was surprising to me at least, was why the human was so bad. I would have expected it to be 100% or so. And we drilled down a little bit in the data that was produced, and we found out that it was essentially a cognitive overload. People couldn't keep up with the speech. It was under real-time requirement, and so they skipped stuff in the context of the lecture and simply didn't produce any output. And that's really interesting, because what that means, that is a limitation that only a human has, because we can put 10 machines to work and let them work this in parallel. They never get tired, and they can do this very quickly, multiple machines, etc. So it's a limitation that humans have, while the machines' limitations are true translation errors and recognition errors. So if we want to improve performance and the machines really improve, then again, data and context becomes critical. So in the final moments of my talk, I want to speculate a little bit about that. Again, going back to my beginning days as a researcher at ATR, I developed something called a time delay neural network, some of you may remember, which was the first instance where a neural network did shift invariance, which today people refer to as convolution or convolutional. And we developed modular networks where you use the hidden representation to build larger representation, which now goes by the trade name deep networks. And so you can build structures which at the time had very small numbers of neurons. And so I counted them in preparation for this talk. We worked at the time on 6,000 weights, and the training data was 0.1 hours that we trained on. Later we went to 40,000 with, I remember still doing this on a supercomputer in Tokyo. 40,000 weights was enormous, and 1 hour of training data. Well, 2 weeks ago, on an evaluation we did in the US, our latest network that pretty much uses the same principles and the same ideas and similar structures has 33 million connections. It uses 1,000 hours of training data, and therefore much, much larger, and gives us a much more significant gain in performance. How long did they take to train? 1 week 20 years ago, 1 week a little bit later, and 1 week 2 weeks ago. So we make our devices just large enough so that our computing just does it in the time that we can bear, and we cannot bear more than a week as researchers. We want to write a paper, etc., and so it has to be done in a week. And so these things will grow with computing. With more computing and with more data, we will also develop larger of these structures, and they will develop better performance. Another thing I want to intrigue you with is what I looked at the text corpora that are now being used for both machine translation and speech recognition. We use text corpora that are now vastly larger than 1 gigabyte of words, 1 giga words, more than 1 billion words, sometimes 2 billion words and so on. If you do the computation, a human being speaks in his lifetime 500 million words. So we're already training on way more data than a human speaks in a lifetime. So obviously that opens up enormous possibilities. I think as we move forward and we get even access to more and more data, obviously the sky's the limit. So these are some pictures I took just a few weeks ago when we had a chance to visit Facebook's data center. Not only Facebook, but Apple and Amazon, and they all have enormous facilities where there are racks and racks and rows of machines. You here have the whole building, and that's only one of the many data centers that are in existence. And so enormous amount of text and data is being processed. So we looked at this a little bit. Google processing 25 petabyte of data per day. Wikipedia uses 6 terabyte dumps. Internet archives contain 10 petabytes and cultural material. Facebook, 2.5 billion pieces of content and 500 terabyte of data each day. Twitter, 500 million tweets per day. YouTube users upload 100 plus hours of new video every minute. We're almost drowning in the amount of data, and it is really up to our creativity to use it. So in conclusion, I think chances are good that by human and machine effort, we will break the language barriers in our generation. And that is just a fantastic realization. We are living in the generation where it will be possible for us to rid ourselves from the differences in languages between us without having to remove the beauty of each other's cultures. And with that intriguing thought, I'd leave you and thank you very much. I'd like to thank you in the context of this award, of course. And again, I'm humbled by it because it is not the work of one person. It really does require a large number of people, particularly when you talk about language resources. I'd like to thank our sponsors for it, our partners in the many projects, many of you here amongst us, our collaborators, particularly at Interact and IMI, where we had spent many wonderful discussions, and then, of course, our colleagues and our students. We have many wonderful discussions in our teams in order to do it. And of course, last not least, Antonio Zampolli, who was a pioneer amongst us to remind us and prepare us for this new age. Thank you very much.
Thank you very much, Alex. We have time for 2-3 questions. I don't see very well if there are hands up. Anyone there to ask anything to Alex?
Go ahead.
you mentioned correctly that the number of data is growing enormously, and as you say, we have already more data than one person hears or speaks in a lifetime. Nevertheless, people are much better still in both speech recognition, speech synthesis, machine translation.
Yeah.
Could it be an indication that the methods that we are using are perhaps not the right methods?
Yeah, and I completely agree. In fact, I put this slide on as a provocation almost. Why is it that we need so much more data than a human learns in a lifetime and still be worse than the human performance? I think the trend is in the right direction, that we will essentially reach that performance, so it bodes well. But yes, I think we have a long way to go. I mean, humans have much more interactive ways of learning. I think perhaps more than the amount of data, I'm also increased by the way children simply learn by interaction. There's never labeled data. It's just by the game and the play and the work with other people, that they learn a code by which they communicate with each other. In a way, I think superhuman performance will probably more easily achieved in machine translation simply because human translation is so hard for us. Speech recognition in our own languages, we're all such experts that it will take a while for us to reach that level, particularly when you add all the complexities of noise and conversational aspects and so on. But I think the trend is really quite interesting in the sense that eventually we will also learn to make the learning staged. I mean, the interesting thing about this neural network learning is that it's not one big learner anymore, but it is actually developmental stages almost, as you like, to build large networks. And it's an old idea we worked on 20 years ago, but it also takes a lot of computing. So I think many of these more advanced models we'd like to try out essentially will eventually be benefited by the improvements in the hardware. It's a bit embarrassing and humbling for us too, because it simply means maybe we should go away for 10 years and sit on the beach and then come back and do our research. So.
Any other question or comment? Yes.
Yes, Alex, I just want to ask when your one-click translator creation system will appear on the market. That's the first part of the question. And second is, that's the more interesting part, I suppose. What steps do you think are still necessary in order to make this possible?
I'm sorry, what was the first part? I couldn't acoustically hear.
The first part was, when will your one-click translation system creation device come on the market? You mentioned that towards the beginning of your talk. You know, you press a button and you get a speech-to-speech
it is
translation
available.
system.
You can download it from iTunes.
Oh, you can do it already. Okay.
Yes. In fact, maybe you can switch it if we have a second.
But I mean, to actually make one for a new pair of languages.
Ah, right.
That's what I really mean.
I'm sorry. Yeah. Adding new languages is, I think, to me, one of these big challenges still, because 6,000 languages, ultimately you can pay for it. Let's face it, right? For 15 languages, yes, well, that's what we have, and 20 languages, maybe 25, maybe 50, but not 6,000. And so I think I would place my bets in any kind of technology that involves ultimately the user community themselves. So if you get people to produce, and there's a lot of interesting work now on human computation where you effectively trick people into playing some game, and as a result they donate speech or language or translation. And again, you know, this is where big user communities of companies like Facebook and so on are fantastic, because with a large user community like that, you can really draw people in and use their data to automatically train and develop such systems. Now, all of that, of course, has to be done in a suitably appropriate way and so forth, but by reaching out to the communities themselves. Another instance, for example, is in these humanitarian exercises. We already had simple little ways in which people on the floor, on the ground, could add new sentences that weren't properly handled, and then the system can adapt from it. So the more we push in this direction, the cheaper it becomes to do it in a new language as opposed to doing it the way we're doing it now. And I think good progress was made. So the first language that we did took us 2-3 years, and then then we did 7 more languages in the next year. So after a while, you really learn a routine how to do this cookie cutter, and then it gets better. But we want to be down to almost no cost in a day, maybe. So.
Last chance. Here, Ed. Is the last one.
So Alex, if the future held 2 options for you, one option being, following the trend that we discover over the last 2 decades, larger and larger and larger storage with more and more shallow transformational knowledge, essentially just big tables to say here's all the English and here's all the corresponding Spanish, or here's all the questions and here's all the corresponding answers, all harvested overnight and things. On the one hand, the engineering solution, and on the other future is what you could call, say, the theoretical solution, where people have thought about and created theories and made like reasoning engines which don't have big tables, they have generalizations and inferences and stuff. Right. Which future would you prefer?
Actually, you'll probably be surprised by my answer. You probably expect me to answer for the first, but I would answer for the second, simply for the fact is that's really why we need so much more data, because it's so dumb. We effectively kind of really store the mapping. But I think the same learning techniques will gradually give us a chance to look at the compositional aspects of language and automatically learn structures in language in a suitable way that is more parsimonious, so that you can, in fact, infer morphology, infer some phrasal structure and syntax. And we have very rudimentary things of that in current statistical machine translation systems, but I think that trend will continue. And you see a lot of publications already going in that direction. So I think I would place my bets on the latter, but still with a heavy dose of learning. Again, I still would think it requires learning and dealing with ambiguities to be successful.
Okay, let's thank Alex again for his inspiring talk.
Thank you very much. Thank you, Nicoletta.